Hello, I'm George Percivall, Vice Chair of the GRSS Standards Committee. This talk is co-authored by myself and Siri Jota-Singh-Khalsa, who chairs the Standards Committee. This talk is about planning the development of remote sensing standards by modeling GRSS as an enterprise. There are three main themes to this talk. First, I'll discuss how standards are crucial in general for information, innovation, and technology. Without standards, the remote sensing industry would not be possible. Second is the core of the talk on how the GRSS Standards Committee is developing a model of the scope and activities of GRSS. This GRSS Enterprise Model, or GEM, will be used by the Standards Committee to identify existing standards, plan for new standards development, and as a basis for standards for education and training. Lastly, I'll close with some of the near-term plans for developing the GEM and the standards. In particular, we invite you to join and contribute to the GRSS Standards Committee. First, let's talk in general about the value of standards to technology innovation. Technology development occurs over many generations of individual products and technologies. Standards capture and promote the use of that accumulated knowledge of experts. It's not an understatement to say that our modern, high-technology lifestyle depends on technical standards. There are general principles at work here. Consider the comments by Herbert Simon, who was awarded both a Nobel Prize in Economics and a Turing Award in Computer Science. Simon identified a key feature of complex system development, that they develop and evolve more rapidly if there are stable intermediate forms. For technology development, standards are the stable forms which foster adoption and promote the highest levels of innovation. Our IEEE organization is a leading standards developing organization for technology. The IEEE Standards Association is 34,000 experts from more than 175 countries working on more than 2,000 standards and projects. IEEE standards are open, market-driven, and consensus-based, and they may also be adopted by formal SDOs like ISO and IEC. Here we see 8 principles of the Standards Association processes. These processes are used by our GRSS Standards Committee. The talks in this session have already introduced and given you details about the GRSS Standards Committee. The committee is developing standards for the acquisition and processing of remote sense data for application to the geosciences. Currently, the GRSS Standards Committee has 4 standards in development and 1 published standard. This talk will describe how the Standards Committee is developing a framework to identify the scope of new standards. To help plan the work of the Standards Committee, we are developing a GRSS Enterprise Model, or GEM. The GEM will be a framework for the Standards Committee's activities. The GEM will identify existing standards and identify standards that should be developed based upon GRSS expertise. GRSS expertise is broad and extensive through its technical committees, publications, education, and conferences like IGARSS. To build the GEM, we will use an established IEEE standard for describing the architecture of complex systems. This IEEE standard accumulates experience from many past architecture developments. The standard provides concepts and methods for modeling of complex systems. The approach of the method is to define viewpoints of the system that addresses the concerns of the stakeholders. We are using this IEEE standard for architecture description to develop the GRSS Enterprise viewpoint. Using the approach of the IEEE standard, we describe the architecture of this system as an enterprise. Geoscience remote sensing is modeled as a complex enterprise of knowledge and organizations. This enterprise viewpoint consists of 3 distinct views. First is the view of GeoRS as a science. Second is the view of the engineering development of specific GRSS systems. And third is a view of the organizations that make up the socioeconomic community. Each of these views describes a perspective of GRSS from a set of stakeholders. The views are mostly independent of each other, but care must be taken to make sure that overlaps between the views are not inconsistent. Let's now look into each of these 3 views. First, The science of GRSS provides a conceptual view of remote sensing physics and the resulting information coming from those measurements. A definition of remote sensing is a starting point. This definition includes the notion of a sensor creating digital numbers and estimating phenomena based upon those measurements. This science view will address several topics, including the different types of sensors, calibration and validation, algorithms for processing the measurement, and scoping the broad themes of the applications to the geosciences. Key to this viewpoint is the conceptual model of a sensor. The working group that is developing the IEEE hyperspectral standard has taken a black box approach to modeling the sensor as a camera. This black box approach is useful in our system approach based upon components. The components are defined by specifying their interfaces and their functionality. Many of the concepts and terminology defined here for hyperspectral are similar for other types of sensors and can be reused. The second view is the engineering and development view. This view considers commonalities of how remote sensing systems are developed, deployed, and operated. The view also addresses differences in systems, for example, the motion of sensor platforms and the various approaches to distributed computing. Different operating stacks are needed and can be best defined based upon existing system developments. This diagram provides one view of the landscape of a distributed computing for Earth observations. On the left, functional descriptions for layers of the stack are provided. On the right, the diagram brings in the business models and example organizations that are building these systems. Diagrams like this are useful in getting a synoptic view of the engineering and development of GRS information systems. The third view, in the GEM, describes the community of organizations that are building the GeoRS systems. Various types of organizations play different roles. The coordination and competition of organization comprises a rich ecosystem. One key element of this view is to understand the several different standards development organizations, or SDOs, that are relevant. The GRSS Standards Committee is working with multiple SDOs to define the standards. No one SDO can do this job on its own. In some cases, GRSS will reference and use standards from other SDOs. One key aspect of the GEM will be to identify where GRSS is the organization best suited to develop new standards. Also critical to the community view is the role of the commercial sector. A recent U.S. National Academies workshop identified key roles of companies in the so-called new space ecosystem. Commercial companies are a key source of rapid innovation of new technologies. Think back to our general model of innovation by Herbert Simon. Specifications from companies can provide those stable forms that enable innovation. This is a call for companies, commercial companies, to contribute their specifications to become open consensus standards in GRSS. So to recap, here again are the three views that make up the GRSS Enterprise Model, or GEM. First, a view on the science of geoscience remote sensing. Second, a view on development, deployment, and operation of the systems. And a view on the community of organizations that are working together. The GEM will be a framework for GRSS to develop the most needed standards. These are no small tasks and requires the experts from across GRSS. In the near term, a workshop later this year will develop an initial version of the GEM. The GRSS Standards Committee working groups are the venues for the development of standards. This is an invitation to you to get involved today. You can contribute your expertise by joining the GRSS Standards Committee. Thank you for your time and attention.